Now it's your turn to try. We just learned the crisscross method. The crisscross method is a faster way of coming up with the real formulas when you put ions together. So I have 1, 2, 3, 4, 5 examples. In just a minute, you'll want to pause the video, look up the charges for each. Remember, if they don't equal each other, you will switch the charges or crisscross them to get the correct formula, and then see if you can get the names. You'll notice that this one is a group with a charge, so I went ahead and gave you the charge. Same thing here, and same thing here. You're not expected to know those. You're just expected to be able to use them. So go ahead and pause the video. We'll come back and see how you did. All right, let's check your work. Starting with the first one, magnesium, when I look at the chart, I see a +2 charge. Phosphorus at the top of the column is -3. I have to ask myself, do they equal 0? No, they don't. And so what do I get as an answer? Well, when I switch them, I get Mg3P2, called magnesium phosphide. Next example. Aluminum's a +3, and I gave you this one. NO3 is -1. Do they equal 0? No. So I switch them. Al1, don't write ones. NO3, 3. Well, it's an extra number, so I put it in parentheses. There's my answer. Aluminum nitrate. Now, you're not expected, again, to know this name. They would give it to you, but it's aluminum nitrate. Has to have the extra 3 from crisscrossing the charges. You can also tell this is why it's so important to know the charges on the chart. So when you start using your chart, that's how you use them correctly. Now let me say this real quick, just as a reminder. When you get your chart for the tax test, these numbers aren't written there. But they're not hard. +1, +2, skip the short ones, +3. 0, -1, -2, -3. Look like this, and you can tell just by looking. Let's see the next one. NH4 was a +1. I gave you that polyatomic ion. Sulfur on the chart's a -3. Excuse me, -2. When you switch them, you get NH4 2S1. Oh, extra number. Put it in parentheses. Notice, the only time I ever put parentheses around groups. It's the only time it'll ever happen. Those are singles, so I don't put parentheses. Parentheses only around groups. This one's called ammonium sulfide. The next one, lithium is +1, nitrogen is -3. They don't equal, so I have Li3N1. You don't write the 1. Lithium nitride. Now notice this is really different from nitrate. So whenever you hear 8, it's a group. Ide, nitride, sulfide, phosphide. They're singles. Pretty simple. And then just as a reminder, well, I'll do this first. K is +1 and PO4 is -3. So you're going to have to switch them so you get K3 PO4 1. And you don't write ones. Potassium phosphate. What happens real quick if I had this Ca and SO4 +2 -2? I would have to give you this one. +2 -2. Do they equal 0? Mark out the numbers. CaSO4 is my answer. Remember, every time, if they equal 0, you just drop them. You only crisscross if they don't equal each other. And you switch them. This is how you use the crisscross method and how you write simple ionic compounds.